So coming here for the first concept in the chapter 2, we have to understand the concept of power. What is mean by power? Okay, what is mean by power? This we have to understand first. For example, if the concept of power is clear, then you can proceed for the calculations. And remember that this is a major topic in the complete designing course. If you are not perfect with respect to this concept, then remember that in future the calculations will be very complex for you. Okay, so in simple terms, I can say that power is nothing but the product of voltage as well as current. E equal to V times of I is nothing but your power. Okay, so in electrical systems, we are having three different types of power. One is nothing but active power, apparent power, and the reactive power. So what is mean by active power? Okay, what is mean by active power? See, don't go for any kind of technical definitions. Okay, we are here, we are assembled here to understand everything in a very simplified manner. Okay, so when you go for the technical definitions, you'll be having some different concepts. Okay, but in simple words, I can say that whatever the equipments which consumes the power are nothing but active power equipments, and the equipments which are measured with respect to watts or kilowatts or megawatts. Okay, these are some of the equipments which are nothing but your active power equipments, and this active power can also be called as true power and the real power also. Okay, active power can also be called as true power as well as the real power also. Everything is same. So coming here for the concept of active power, as I've told you, whatever the equipments which consumes the amount of power and nothing but active power equipments. Okay, and the units will be in watts, kilowatts, and the megawatts. For example, in my classroom, I'm using some 4 lights and 4 fans. For example, I'm telling you. Okay, that means what? The light is measured with respect to concept of wattage. Okay, so that is nothing but your active power equipment. Okay, I'm using a fan. So at the end, the fan is measured with respect to wattage. Okay, and the fan will also consume the amount of power. So in short, we can say that these are your active power equipments. Okay, these are your active power equipments, and the formula for the active power equipment is nothing but P equal to root 3 VI cos phi for the 3-phase system. Okay, this is the formula for your active power system for the 3-phase system, and for the 3-phase I am going with a voltage of 415. It can be 440 also, that depends upon the country, but I am going with respect to 415. And for the single phase, the formula is nothing but P equal to VI cos phi. The single phase 230 volts. Okay, there will be no root 3 for the single phase systems. And the cos phi, what is meant by cos phi? The cosine angle between the voltage and current. In the last class, I have told you the phasor diagrams of the resistive load, the inductive load, and the capacitive load. At that moment, I have told you the angle between the voltage and current. So the minimum power factor which we are getting from the substation is 0.8. In some countries, we are getting 0.85 also. When you go for the UAE, in the main cities, you can find 0.85. Okay, means efficiency of the system is 85%. That means the losses are less when the power factor is good. Okay, so these are two basic formulas when you are going with respect to the concept of active power, true power, or real power. Remember that all these three things are same. When you go with respect to Gulf countries, or when you go with respect to a country like India, we call it as active power. But when you go for the European countries or Western countries, they call it as true power or real power. Everything is same. And now the question comes, when we have to use the 3-phase formula, when we have to use the single phase formula. Remember that as per the state electricity board. Okay, remember that as per the state electricity board, it has been defined that if the load consumed in your particular home is up to 5 kilowatt, we can go with respect to single phase system. If it is more than 5 kilowatt, then you have to go with respect to 3-phase system. This is internationally satisfied. Okay, so whenever the amount of load, whatever you are using in the home or in your building, is less than 5 kilowatt or up to 5 kilowatt, we can go with respect to single phase system with respect to 230 volts. When the load is above 5 kilowatt, you have to go with respect to 3-phase system. Okay, and remember that the active power can also be represented in terms of HP also. What is HP stands for? Horsepower. Usually the mechanical equipments are measured with respect to the concept of horsepower only. Okay, so 1 horsepower is nothing but 746 watts, because at the end we are getting wattage now. What I have told you, whatever the equipments which are measured with respect to watts or kilowatts or megawatts comes with respect to your active power only. So at the end the HP concept comes with respect to watts only. So when compared to 5 kilowatt, we can see that 6 HP will give you almost like 5 kilowatt of load. Based upon that, okay, if any question has been asked with respect to 6 HP of load, we can say that we can run that particular load with respect to 3-phase. But in the real time, this will single phase. But in the real time, this will not happen, because about 2 HP we are running the machines on 3-phase. Even if the machine size is more than 2 HP. Okay, but with respect to theoretical concept, we can go to respect to 6 HP, because 6 HP will give you almost like 5 kilowatt of load. Based upon that. Coming for the apparent power, what is meant by apparent power? The equipments which gives us the power are nothing but active apparent power equipments. The equipments which gives us the power. Okay, what are the equipments which gives us the power or which feeds us the power? Nothing but your transformer, your generators, your UPS, inverters, etc., etc. And all these equipments are measured with respect to kVA, MVA, or VA, etc. Okay, so whatever the equipments which are measured with respect to volt ampere or kilovolt ampere or the megavolt ampere, these are the units of your equipment. Okay, and the formula for that will be nothing but P equal to root 3 VI. There will be no cos phi because this is not a load. These equipments are giving us the power. So in that case, we will not consider the concept of cos phi over here. And this is for the three-phase formula. And for the single phase, we don't find a root 3. P equal to VI is a single phase 230 volts. And here we can see up to 25 kVA, we have to use a single phase formula. About 25 kVA, we have to go with respect to three-phase formula. Okay, so coming for the reactive power. So what is meant by reactive power? The equipments which are used to improve the quality of power. In the last class we have seen, okay, the capacity load. What I have told you, the capacitor will provide the back EMF as well as a quality tool equipment for the inductive load. Okay, so in short I can say that the capacitors are used to improve the quality of power. Okay, so remember that for the single phase system, the manufacturer is responsible for the capacitor sizing. For three phase system, we are responsible. So based upon that, there is no formula for the single phase over here. Directly we have a three phase formula. Okay, directly we have a three phase formula, and the units for this is nothing but VAR, kVAR, even we are having MVAR also, but MVAR is not used. Okay, so volt ampere reactance, kilovolt ampere reactance, or megavolt ampere reactance. And here the formula will be P equal to root 3 VI sin phi for three phase 415 volts. There is no concept of single phase over here. And for the sin phi, what is the value we are getting? 0.6. Why we are getting 0.6? Because in the basic intermediate, in the 12th standard, we have studied that sin theta equal to under root of 1 minus cos square theta. This is a basic formula what we are having. Okay, so what is the cos value we are taking over here? Nothing but 0.8. Okay, so when you substitute this under root of 1 minus 0.8 whole square, you get something like 0.64. Nothing but under root of 0.36 is 0.6. So whenever the power factor is 0.8, this will be 0.6. For example, in some countries, especially in UAE, we can see the power factor is something like 0.85. In that case, okay, again you have to substitute and you have to change this value. Substitute here 0.85, don't substitute 0.8. This value will vary. Okay, and I have mentioned in note also over here that kVAR is used only for three phase. Okay, there is no formula for the single phase, because for single phase the capacitors will be with respect to microfarads, etc., etc. I hope it's clear for everyone. I request everyone to please go through the screen right now. Before going for the calculation, now we are having the formulas with respect to the calculation. Before going for that, just go through this. I'll give some 2 minutes of time, just go through this for everyone. Okay, so coming for the problems. Okay, so what is the question over here? What is the question we are having over here? Nothing but solve the following. Okay, we are having some examples over here. We have to solve these examples. Find out the current. Current in the term of symbolic form, we are writing it as I for all the given loads. Okay, I'm having the load something like 500 watts. That means what? To run this 500 watts of load, how much amount of current is required? That is a question. For example, I'm having some 200 watts of load. To run this 200 watts of load, how much amount of current is required? That is a question over here. So you are having 500 watts, 3000 kilowatts, 75 kVAr, 12 kVA, 1200 watts, 50 HP, 12 kilowatt, 5 kVAr, 28 kVA, 175 kVA, 5000 watts, 18 HP, 35 HP, etc., etc. So for all these loads, we have to see how much amount of current is required individually. Okay. So with respect to the previous topic, we can say that here is the concept of watts. So when we are having the concept of watts, means what? This is the active power equipment. Okay, because what I have told you, the equipments which are measured with respect to watts, kilowatts, or the megawatts, and nothing but active power equipment. Okay, and till 5 kilowatt we can go with respect to single phase. Above 5 kilowatt we have to go with respect to three phase system. So 500 watts in the sense what? This is a single phase, because 500 watts will give you almost like 0.5 kilowatt of load, because 1000 watts equal to 1 kilowatt. Okay. So single phase 230 volts. So what is the formula we are having? P equal to VI cos phi is a formula. Okay, this has been defined. Now as we know, P is 500, the power is 500, voltage what we are taking is 230 for the single phase, cos phi is 0.8 what we are getting. We have to find out the value of phi. So I equal to P by V times of cos phi. Okay, so what is the P we are getting? Nothing but 500, voltage is 230, cos phi is 0.8. When you substitute this, okay, see, in order to get the I value, the same formula we can write in this way also. So much we are getting 2.71 amps. This much amount of current we require to to run this much amount of load. Next we are having 3000 kilowatts. Kilowatt is again your active power and more than 5 kilowatts, so it's a 3-phase system. Okay, so first check your units. In what units the system is in. So 3-phase 415 volts is the formula. So we know that P equal to root 3 VI cos phi is the formula over here. So P is 3000, V is 415, cos phi is 0.8. So the same formula I can write as I equal to P by root 3 V cos phi to get the I value. So which gives you 3000 times of 1000. Why we are multiplying with respect to 1000 over here? Because the value is in kilo. Divided by root 3 into 415 into 0.8, which gives you how much? 5217 ampere. Next is 75 kVAr. So 75 kVAr is nothing but P equal to root 3 VI sin phi. Okay, there will be no single phase formula over here. Directly we have a P equal to root 3 VI sin phi. So P is 75 kVAr, V is 415, sin phi is 0.6. Why? Because the cos phi value is 0.8. Previously we have seen. Okay, I equal to how much? So I equal to P by root 3 V sin phi, which gives you almost like, when you substitute this, it's 173.9 amps. And I repeat that, okay, you will get this answer only when you use scientific calci. If you are using the mobile calci or if you are using the computer calci, you will not get the answer. Use scientific calculator only to get this solution. Okay, and being designer, as I've told you in the first class also, the designing works with respect to calculations only. The designing works with respect to calculations. Okay, and you have to be hands-free how to use the scientific calci also. So better to make the habit with respect to this concept only. Next we are having 125 kVA. kVA is nothing but apparent power. More than 25 kVA is nothing but 3-phase. So 3-phase formula is what? P equal to root 3 VI is a formula. So P is 125, V is 415, I equal to how much? So based upon that we are getting how much? 173.9 ampere. This much amount of current is required to run this much amount of load. Next we are having 1200 watts. Nothing but 1.2 kilowatts. 1.2 kilowatt nothing but less than 5 kilowatts. So it's an active power. Okay, so the formula is single phase only. So P equal to VI cos phi is the formula. P is 1200, V is 50, cos phi 0.8, I we have to find out. So much we are getting? 6.52 ampere. This much amount of current is required to run this much amount of load. Next we are having 50 HP. So 50 HP in the sense 1 HP 746 watts. So 50 HP in the sense 50 into 746 will give you 37.3 kilowatts. And what is the formula we are having? P equal to root 3 VI cos phi is the formula we are having. Based upon that we are getting a load current of 64.86 ampere. But that means to run 50 HP of machine we require this much amount of current. Next is for the 12 kilowatts. Okay, so 12 kilowatt is nothing but again it's an active power more than 5 kilowatts, so it's a 3-phase system. So the formula is P equal to root 3 VI cos phi. So based upon that we are getting the current as 20.86 ampere. Next 5 kVAr. Okay, nothing but reactive power and there is no single phase. Directly we have to go for the 3-phase formula. P equal to root 3 VI sin phi. So P is 5 kVAr, V is 415, sin phi 0.6. So much we are getting 11.59 ampere. This much amount of current is required to run this much amount of capacitor bank. Again 28 kVA. Okay, 28 kVA in the sense apparent power more than 25 kVA, so it's a 3-phase. P equal to root 3 VI is the formula. So based upon that we are getting the result as 38.9 amps. Again we are having 175 kVA. Okay, so P equal to root 3 VI is a formula. P is 175 kVA, V is 415, I equal to how much? So we got how much? 243.4 ampere. This much amount of current is required. Again 5000 watts. I repeat again, this is 5000 watts, something but 5 kilowatt. When you convert this in terms of kilowatt, it is how much? 5 kilowatt. So what is the rule we are having? Till 5 kilowatt it is single phase. Even if it is crossing, if you are getting 5001 also, go for the 3-phase system directly. So P equal to VI cos phi is a formula. P is 5000, V is 230, cos phi 0.8. So much we are getting 27.17 ampere. This much amount of current is required. Again 18 HP. So 18 multiplied by 746 will give you 13.42 kilowatt. Again more than 5 kilowatt. So 3-phase formula. P equal to 3 VI cos phi is a formula. So based upon that we got a current of 23.3 amps. Next we are having 35 HP. So for 1 HP is 746 watts. 35 HP in the sense 35 into 746 will give you 26.11 kilowatts. So more than 5 kilowatts, so 3-phase system. P equal to 3 VI cos phi is a formula. So we got a current of how much? 45.4 ampere. This much amount of current is required to drive this much amount of motor. Okay, so after every concept I'll be giving you the assignment. So this is the assignment. Okay, so first go through this in detailed manner. After going through this, find out the current for these loads now, like 100 watts, 1000 kilowatts, 55 kVAr, 18 kVA, 20 to 100 watts, 58 HP, 10 kilowatts, 15 kVAr, 128 kVA, 75 kVA, 4000 watts, 28 HP, 55 HP, etc. So for all these different types of load, we have to calculate the amount of current, how much amount of current is required. Okay. So I request everyone to please submit your assignments before going to the next class. Okay, for the online candidates, just do one thing. Okay, go with a manual calculation. Don't go for any kind of Excel sheets or any kind of worksheets. Go with respect to manual calculation only. Okay, take a snap and you can forward me by means of mail. Okay, or you can also forward by means of WhatsApp also. No worries. I request everyone to please go through the concept now before going to the next concept. Right now in the class. Remember that the same concept is very important when you're going with the main calculation, when you're finding out the cable size, when you're finding out the short circuit value, etc. etc. Okay, this topic plays a major role. So I request everyone to please go through this topic. Okay, and hopefully today everyone have received the material. I request you to please download the material. Okay, and make a hard copy so that in the class, okay, whatever we are following, you can follow the means of in a manual mode also. So I request everyone to please make the hard copy of the material also. Coming for the next topic, nothing but solve the following. Okay, now the question is totally reversed. Previously, what was the question? There was a load. Okay, we have to find out the value of current. We have to find out the value with respect to the kVA value, with respect to the kilowatt value, with respect to the kVAR value. But now the question is totally reversed. Here we are having the value of current. We have to find out the amount of power in terms of kilowatt, nothing but active power and apparent power, kVA. Okay, so here we are having the different concepts. So for active power, to calculate in terms of watts or kilowatts. Okay, what is the rule we are having over here? Till 27 amps, it's a single phase system. About 27 amps, it's a three phase system. Okay, remember this values. 27 amps is for the single phase. About 27 amps, whenever there is a requirement, it is a three phase system. For the apparent power, nothing but for the volt ampere or kVA or MVA, whatever it is, up to 18 amps, it's a single phase. Above 18 amps, it's a three phase system. Okay. So here, what is the question we are having? 800 amps. We have to find out the amount of load. Means how much amount of load we can put in terms of kilowatt for 800 amps of current, and how much amount of load we can put for the kVA in 800 amps of current. Okay. So for active power, first we will substitute for the active power in watts or kilowatts. So we know that P equal to root 3 VI cos phi over here. Why I have taken this formula? Because 800 amps is more than 27 amps. Because what is the condition we are having? Till 27 amps is a single phase. About 27 amps it's a three phase system. Okay, so I equal to 800 amps we are having, voltage is 415, cos phi 0.8. We have to find the P value. So much we are getting? P equal to root 3 by cos phi. So P is P equal to root 3 for the three phase, voltage is 415, current is 800 amps, okay, cos phi 0.8. So based upon this we are getting how much amount of load? 460.0 kilowatt of load. Okay, next we can see we are having the apparent power. So P equal to root 3 VI is the formula. Why I have taken this formula? Because 800 amps is more than 18 amps. You can check your load over here. Up to 18 amps, it's a single phase. About 18 amps, it's a three phase system. Okay. So I is 800 amps, V is 415, P we have to find out. So much we are getting again? Nothing but 575.0 kVA. For 125 amps. The next question is 125 amps. You have to find the kilowatt value and the kVA value. So formula is what? P equal to root 3 VI cos phi. Okay. 125 amps is more than 27 amps as per the rule. So I is 125, V is 415, cos phi 0.8. So here how much we are getting? 71.88 kilowatts. For apparent power, P equal to root 3 VI. So 125 amps is more than 18 amps. Okay, so based upon when you substitute all these things, we are getting 89.85 kVA. Next is for 168 amps. Okay, so V equal to root 3 VI cos phi is a formula. Okay, 168 amps is more than 27 amps. I is 168, V is 415. So when you substitute this, you will get 96.60 kilowatt. For apparent power, this is a three phase because 168 amps is more than 18 amps. Again, we are getting a load of 120.75 kVA. Next for 225 amps. Okay, so P equal to root 3 by cos phi is a formula because 225 amps is more than 27 amps. Okay, so we are getting 129.3 kilowatts. For apparent power, P equal to root 3 VI. Okay, because 225 amps is more than 18 amps. So we are getting 161.73 kVA. Again for 12 amps. Okay, so this is single phase, P equal to VI cos phi because 12 amps is less than 27 amps. The condition is still 27 amps. So I is 12 amps, V is 230, cos phi 0.8. So how much we are getting? 230. There will be no root 3 over here. I is 12, cos phi 0.8. How much we are getting? 2.20 kilowatts. For apparent power, P equal to VI, 12 amps is nothing but less than 18 amps. So I is 12 amps, V is 230. Multiply V into I will give you 2.3 kVA. Okay, and this is the assignment. So you have to find out the load for the 500 amps of current, 100 amps of current, 333 amps of current, and the 10 amps of current. Okay, this is the assignment, and the same procedure you have to follow. Okay, submit in a manual mode. Don't go for any kind of Excel sheets or any kind of worksheets. I request everyone to please submit, hopefully by tomorrow. Okay, hopefully by tomorrow, go in a manual mode and use scientific calculation to get the answer. You can submit me by means of mail or by means of WhatsApp. No worries. Okay, take a snap or scan your page. Again, you can forward me. Let's go through once for the previous topic before going to the next concept. Now coming to the next concept. Okay, this is very interesting. Remember that the thumb rule for calculation of current. Okay, means what? I am having an amount of load. Okay, with respect to that load, I have to calculate the amount of current value. The same thing we have seen in the previous topic also. Okay, but that was the actual method. So here we are going in a shortcut method. Okay, the other name of shortcut what I am taking here is nothing but thumb rule. Actually, the concept of shortcut will give you an approximate answer. But if you want to work in a detailed manner, go with the previous concept only. Okay, so thumb rule in a sense shortcut method to calculate the amount of current with respect to the load. Okay, so for example, for the secondary side or for the low tension side or for the start side or output side of transformer, as we know, the transformer will have the two sides. One is the input side, one is the output side. Okay, so the output side of transformer can also be called the star side or the low tension side or the secondary side of transformer. Everything is same. Okay, so whenever you are working with respect to this particular area, okay, and you're having some amount of load like something like 500 kilowatts, multiply with respect to 1.74, you'll get the amount of current value to overcome all the previous calculations. Again, here you can see multiply with respect to 5.43 whenever you're working with respect to single phase system. Okay, so you have to remember this multiplying factors 1.74 or 5.43. This is for the three phase, this is for the single phase. For the apparent power, you can see for three phase the multiplying factor is 1.39. For single phase the multiplying factor is 4.32. Okay, and for kVAR, nothing but for the reactive power. Okay, we don't have any kind of single phase, so directly we have to multiply with 2.33. Will give you the amount of current value. Okay, so these answers are almost like 99% will work. 99% it will work. Okay, 0.1% to 1% it will vary. That's it. And if you're working with respect to primary side or for the high tension side or delta side or input side of transformer, okay, and if the point of supply is 11 kV for your building, so multiply with respect to 0.052 means the input side of voltage I'm talking about. If the input side of voltage is 33 kV, okay, multiply with respect to 0.0174. Okay, these are the multiplying factors. Now we will see some of the examples for that. So for secondary side or for the low tension side, for star side or output side of transformer. For example, I'm having some 3000 kilowatts. So 3000 kilowatts, obviously more than 5 kilowatts, so it's a three-phase system. So multiply 3000 with respect to 1.74, you'll get the amount of current. Okay, or else what you have to do, you have to go for the P equal to root 3 VI cos phi formula. Again, you have to substitute everything. You'll get this answer. You can cross verify, you'll get the same answer, inshallah. Again, multiply the load with respect to your 5.43 for single phase, 0.5 kilowatt, I think but 500 watts. Will give you how much? Something like 2.71 ampere. For kVA, for apparent power, for example, 125 kVA, nothing but more than 25 kVA is nothing but three phase only. So 125 kVA we are having, so 125 into 1.39 will give you almost like 173.75 ampere. For example, for the for the single phase, actually this is for the single phase. Okay, it's a typing mistake over here. So kVA is nothing but 10 into 4.32. For example, 10 kVA is there. So 10 into 4.32 will give you 43.2 ampere. You can cross verify the same, you'll get the same answer. For example, you are having 5 kVAr, multiply with 2.32, you'll get the current value, 11.6 ampere. The same thing you can see for the primary side or high tension side or delta side or input side of transformer. If the point of supply is 11 kV, if the kVA is 500, multiply with respect to 500 into 0.052, you'll get the ampere rating. If the point of supply is 33 kV, okay, so multiply 630 with respect to 0.0174, you'll get the 10.962 ampere. Okay, so the thing is nothing but whatever the assignments I have given you, you have to follow with respect to this concept also, you have to go with respect to this concept also. Means I need the answer with respect to this values also for this concept, okay, with respect to the other concept also. So that you will be getting the perfection with respect to the formulas, where which formula we have to use, where which type of multiplying factor I have to use. I hope it's clear for everyone. Okay, so here you can see for everyone I have provided these links. Okay, so right now for today's class, you can download this electrical notes. Okay, just right click on this one, go for the open link in new tab, and you'll be getting the new tab. Okay, so here you'll be having the option to download. Okay, just go for this option. After downloading this, okay, the password I'll be sending you to the concerned mobile number. Just ping me on the WhatsApp. I'll be sending you the password. Okay, to open the document. The same document what I'm referring is available with respect to this link. Nothing but the notes, electrical notes. Okay. Again, you have to download this AutoCAD software also, because very soon we are going to start the AutoCAD also. Again, the same procedure. Right click, open link in new tab. You'll be getting the option to download this. Okay, download again the same thing. These are time consuming thing, the softwares, because almost like 4 GB it is. Okay, so in the same way, download everything, and I'll tell you when to install. You can install the AutoCAD right now itself, no issues. And I am going with 2012 version. If you are already using AutoCAD software with respect to any of the higher versions, you can also go with that also. Okay, so hopefully within 2 or 3 days we are going to start the AutoCAD also. Okay, so just download this as well as this. It is very important. And I request everyone to please make the hard copy of the notes as well as the material. Okay, because whatever I'm telling you, if you want to maintain the running notes, you can maintain the running notes just side by to your particular step, so that it will be very easy for you when you're going with respect to the references. Okay, so just go through the assignment right now. Okay, after the class, inshallah in tomorrow's class we will go with respect to chapter 3. Okay, so inshallah tomorrow we are going to the theoretical chapter 3, inshallah. Okay, so in tomorrow's class we will go with abbreviations. Okay, so covering with some theoretical part as well as some real-time concepts, inshallah. Okay, fine then, inshallah. As these are the initial classes, so we are not going in a faster mode. Hopefully once the admissions got closed for everyone, we'll proceed for the drafting, covering with some more technical abbreviations, inshallah. Okay, so okay, fine then. Everyone take care, have a nice day. Thank you.